Welcome to this topic on ice and rain protection for the Airbus A320 family. We are going to cover the different protections that we have for against ice and rain. So we don't want to have the formulation of ice on certain components. We also want to have the highest visibility possible for the pilot. So we're talking about protection against rain, especially very heavy rain, against windshields and windows, etc., so that we, again, visibility is at peak. So what different areas are we going to look at here? We have, we're going to start with the cockpit. So this is not going to be broken into sessions. It's going to kind of be an overall of the ice and rain protection systems. And of course, with all systems, we're going to also have controllers for each of those regions where we have that protection and for those components. So number one, we're going to look at the cockpit. What do we have there in the cockpit to protect against ice and rain, or that pertain to that? Number two is going to be the water. Water can freeze, and ice can, obviously when it gets down below freezing temperatures in the aircraft, we want to make sure that any waters that water that we have, okay, we're going to be talking about wastewater protection and also the potable water. So we don't want to make sure those don't freeze and that we have serviceable water. Number three is going to be the engine air intakes. We also want to ensure that there's no ice that's forming along those intakes. Number four, most important, it's all important, but the probes. All the sensors, your TAT sensors, all your probes, the static, your static probes as well, your pilots, your pilot probes. All of those also need to be free of any ice formation on them, because if they do form, and you probably know this already, but we've had wrong navigation, okay, pilots getting wrong information from those sensors because ice was formed on them, okay. And our last one we're going to be looking at is the protection system for the wings, okay. We want to make sure we don't have the formation of ice on the wings, okay. So let's start with the cockpit, and just to give you kind of a helicopter's view of the different things we're going to be talking about. There isn't a whole lot, but you still need to know, obviously, have an awareness about it and familiarity with it. But we have the windshield. So besides obviously the windshield right in front of the pilots as they're sitting down, but we also have the windows on each side. So from captain's seat to first officer's seat, we have the windshield in front, but we also have those side windows. So we're going to look at that system there as far as protection against ice formation. And then also we're going to be talking about rain protection in the cockpit, obviously against being able to have visibility, for the windshield and the windows around, to be able to have some clarity there. So we also have the wipers. We want to make sure those are working properly. Of course, we have the control, so we will make sure the motor is not burnt out. Otherwise, we're not going to have the wipers, moving, right? So we're going to kind of go into that and understand a little bit more about what's happening there. And then, of course, we'll get into water. So when we talk about the windshield, there's also, in addition to just preventing the formation of ice, okay, and being proactive with that, we also are looking at defogging, right? Because we don't want to have fogged windows, so it has to do with visibility. And so there's also a defogging system of the windshield in order to keep that that clarity going. And the two systems, well, I'm mentioning, because I'm about ready to mention electrical heating system, we have two sources of power in order to operate the protection systems in these various areas I just mentioned. And besides your electrical power, you're going to also have a pneumatic power. So here on the anti-ice protection for the windshield, it is electrical heating that provides that protection for both the windows and also the windshield. Okay, so how does this work? Well, we have the system that's automatically started. So when it comes to the windshield, as soon as the engine is started up, then it's going to trigger that anti-ice protection system. You can control it through the push button controls that's on you know, in the cockpit. So there is a push button switch for that to operate. Now, the way that I said, remember there was captain's seat, you got first officer seat. This anti-ice protection system is actually split. So you have your kind of left side, right side. So you have two systems operating, okay, one obviously for the left side, one for the right side, and they each have their own controller. All right, so they each have their own controller in order to ensure that visibility is there. We have defogging, and we also have, you know, the anti-ice for the windshields, and also for the two windows on each side. Okay, you have a fixed and a when we get to Windows, if you haven't already gone to Windows topic, there's a sliding one, and you also have a fixed in the aft side. So you also have your temperature sensors, depending on the configuration, you know, whether it's Airbus, and we're going to have Rick talk a little bit more about maybe some differences there. We will talk about differences in like kind of a specified video, because we just want to get you the kind of the foundation across the family of Airbus A320. So you're talking about your 18, 19, 20, and then kind of see the differences that might be there. So don't lock yourself in again to, you know, just saying, okay, well, this has 3. Well, it depends, but just know that we have some temperature sensors here that are installed inside of each windshield in order to, you know, be able to monitor and control that heating system to prevent that ice, you know, from even starting to form. Okay, now interfaces that we have with this protection system is the engine interface vibration monitoring unit. Okay, that's just to make sure that we have control of that heating. And then you know, the other thing too that you have is the shock absorbers on the landing gear. And so it's going to interface with those, just again to ensure the selection of the heating mode, and that's for the windshield. And of course you got your CFD IU unit, okay, so your interface unit, centralized fault display, and also your SDAC. Okay. Also, you have 2 heating power levels for the windshield. You have one for that's on the ground, and then there's one for in-flight only. So just to note, so you know, those are 2 different levels, you know, depending on whether ground or in flight. So you've got that. And then, of course, it's going to have to detect, you know, those temperatures. That's what those temperature sensors are there for. Is it now, you know, at that point where that system needs to be activated? Okay. So with here, we're talking extreme temperatures that are given, that we have, that they've established. We're talking about temperatures being at, you know, 140 degrees Fahrenheit. Okay, that's overheat. So you can have too much there as far as temperature sensing, or it's, you know, below, so 76 degrees Fahrenheit below 0. And that's going to be corresponding to the sensor in the short circuit. So you've got an open circuit and a short circuit. Bottom line is, just know that it's going to be sensing something when it gets too hot. So it hits 140 degrees Fahrenheit. You know, we're talking about an overheat situation, so it's going to be sensing that. And then at 76 degrees below 0 on Fahrenheit. Okay, so it gives you an idea there. And then the controls that you have, what you're going to see, there's going to be a probe window heat push button. And when the push button is in the on position, it's going to be illuminated blue. So blue means that it's on, and that there's going to be heating going to those windows, okay, as well as the probes. Okay, we'll get into that, but that's what that probe window heat push button is about, because it's also for the probes, but it's definitely for the windows. Okay, so and just kind of keep in mind too, there's the anti-ice. You know, you have it for the left and the right. And you have warnings there that can be there for, because we're warning against what? Remember, we're always mentioning about whether something's overpressured, you know, you have too much heat, or, you know, something's getting too hot. So here we have an overheat indication. The anti-ice left or right window warnings can be illuminated. They can be, you know, certainly indicated there when there's an overheat of the window temperature. Okay, and that's in pretty hot weather, so we don't want that either. Okay, so and then of course we have the way that the structure of the aircraft is designed is to create an insulation. It's just to kind of, again, prevent too much of that solar heating. kind of keep a barrier from that heat from the sun. And there's a picture you can see with kind of where that's located on the panel. Probe window heat, there it is. It's the way it's on the panel. And then you got for engine 1 and engine 2 your fault buttons, as well as for your wings. There's also your the window heating. Besides your windshield, you got the heating. Remember I said you have a fixed and sliding window on each side. Okay, so you have heating elements, around there. Be careful because, it's electrical heating, so you want to be mindful of the fact that, there's current running through there in that loop. So again, just follow the safety protocol for all of that when you're doing any kind of repairs, any replacement of anything. Your controller, okay, this is like the brains of it, is your computer for the control of the heat. So what is it going to do? It's going to regulate that temperature. It's going to monitor it as well, and it's also going to kind of have an inbuilt safety. It's a self-sustaining computer, being able to monitor itself and also monitor to make sure things are, regulated where it needs to be with that temperature, at that temperature on the windshields and the windows. Okay, and of course there's one for each side, just like when we're going to talk about the probes in a little bit. We have three channels on the probe side, and each of those channels has its own controller. So here with the window heat controller, there's one for each side. Okay, so on the left side there's a heat controller, and then on the right side there's another controller. Okay, and those are indicated by WHC1 and WHC2. In case you see that written out, that's the abbreviation for that. Okay. The regulation minimum, you've got tolerances, as I mentioned before. So remember I was saying about kind of a max min there with the temperatures. Well, here we have a range. So we're talking about tolerances between 30 and 38 degrees Celsius. Okay, that translates, if you need it in Fahrenheit, that's translating between 86 and 100 degrees Fahrenheit in a little bit. So that gives you an idea. And then, temperature sensor cuts off the heating when the temperature is plus or minus around 140 degrees. Okay, that's when it's gonna cut off that heating. All right. Now, the controllers, of course, are located in the avionics compartment, just like all the other computers / controllers, right? It's what they are. So in case you want to know the location of that, it's in the avionics compartment. And again, I don't want to mention doors. Your access doors, it depends on the aircraft, but I just want to let you know, obviously there's an access door for that near the avionics compartment. All right, and so what kind of faults and warnings, can we have? I was talking about this here. Well, we can, if we have the detection of extreme temperatures, or there's a failure, okay, of one of the sensors, that's going to cause a warning to come on or be indicated in the cockpit. Okay, so those are the times that's going to happen. The faults of the heating system, and it's going to be for each window. Okay, those are going to be showing up on the ECAM display unit. Remember, we have each of them has their own computer, so they're going to be sending that data over the ECAM, and it's going to show what that fault is. Okay, so your controllers are going to be identifying that faulty component, whatever it is. It's going to be sending that data over. It's also going to store it in memory. So that's what it's doing there. Those warnings are going to be also sent to the flight warning computer, your FWC. Okay, so you have your window fault, you have a windshield fault, again, extreme temperature, or there's a failure of one of the sensors. That's going to trip it, meaning it's going to send that signal over to the ECAM. Now your bite tests, you do have your bite test with the controllers. If there's a loss of electrical power, that's going to be indicated, okay, as a failure. You also have contactors that are part of the controllers. There's also a protection against a lightning strike. Okay, we've covered actually before, we've covered about how there's material that is kind of a coating on some components, and again, that's due to, you know, just a protection in case there's a lightning strike. For those particular components that are extremely critical, there's certainly that protection there with that component. All right. So with the bite test for window heating, you have, of course, all these different circuits that are going to be tested to make sure that there's not a fault in them. Of course, if there is a fault, that will be detected and that information will be transferred. Okay, and that'll show up, of course, on your leg reports, okay, along with your class 3 faults, anything there. All right, so let's look about rain. And you know, ice is certainly something we don't want to have formulating on the windshield and the windows. But what about rain? Rain can be light or it can be very heavy. We know that just in general, when we're driving a vehicle, if the rain's really coming down, you know, pretty heavily, it's difficult to see. And so here we want to make sure that the pilots are able to have as much visibility as possible. So we want to remove that rain as quickly as possible. So the way that that's going to be doing this, there's 2 wipers, okay? So you got the wipers there. We've got one for the left side, one for the right side, right? Okay, left windshield, right windshield. And those wipers are there, obviously, to remove that rain as quickly as possible. Okay, the wipers also have like a parking position. And that is not in the way of where the pilot's eyes are, where they actually would see forward. So those are kind of off to the side of that view. And that's where they're kind of like stowed, if you will. But that's its parking position. It does have that there. Okay. Okay. And there's some protection too with the wipers so that it doesn't have debris that can actually rub up against the windshield when it's actually in motion. Okay, now your wiper control switch, that's located on the 21 VU and 22 VU panel. So wiper control switch is there. You've got obviously you've got your off, slow, fast. Okay, so those are your choices on the wiper control. And then there's also the selected off. Then when you have that, you're going to have the assembly stop, and it's going to stop in that parking position I was saying, and not dead center, but it's going to clear that visibility, that, you know, that view where the pilot and first officer would be, you know, seeing out that window, that windshield. Okay. All right, and then there's also the motor. Motor's important. Okay. The motor, you know, so we want to make sure that's, you know, obviously functioning properly. But you got a motor and converter that's put together. It's an assembly, so you're not having to, you know, I mean, if one is diagnosed as not working, you just, you know, switch out the entire assembly. But the motor's there. It has a thermal protection. That's going to be protecting the electrical components as well as your mechanical. And the assembly also is going to kind of give some sweeping angles. So it controls angles of that wiping as it goes over the windshield. Okay, and of course your motor, I'm not going to get all the details because, you know, motors have some basic components to them, as you probably already know. But you know, you've got your permanent magnet in there. I mean, it's typical of your motors. Your rotation speeds. You got your slow inverted rotation for the parking position, and of course you got direct current there. Okay. All right, so what about to identify just your basic, you know, physical components with the wiper? You've got the arms, you got the blades, okay, so pretty standard here with the actual wiper itself, okay. All right, so that kind of, you know, that gives you pretty much what we have as far as protection against ice and a way to just, you know, remove the rain as quickly as possible from the windshield is what we have in the cockpit. Okay, so now I want to talk about a little bit on the water on the aircraft. Okay, because water can freeze. We don't want to have that. And we're not just talking about, you know, potable water. We're talking about wastewater. That's just any kind of water that's sitting or somewhere in the lines. We don't want to have them freeze. So just to give you a rundown, okay, is what are the places, where are the locations that you want to make sure you have some heat there, available. Obviously the lines. So, the drain lines, you want to make sure you have a heater there, and then the water servicing panel, you don't want that to freeze. So, you've got a heating, you got a heating thermostat there at the panel to control that heating. And then you also have heaters where, for the water, the drain and the flush nipple, okay, those that have heaters as well. So, just to give you an idea where those need to be. Obviously the lines, you don't want to have those freeze up. Okay, so water, your wastewater, that's going to be coming from your galley and also lavatory wash basins, and that's going to go right through the drain lines, right, and the drain mass to the atmosphere, and all of that can freeze if there's not a way to have heat along the way. So there is electrical tape heating elements that are following the lines. So again, when you're doing maintenance on anything where there's electrical, any type of electrical system there, please be mindful, follow the safety procedures regarding working around electricity to avoid any kind of electrical hazard to yourself. All right, so wastewater, drain lines, you're going to have the heated drain mast, forward and aft of that goes into the atmosphere. You got the drain mass assembly that's there. That's just going to be your drain tube with those heating elements I was just saying. It's an aluminum alloy housing, just so you get an idea of what this is made of. You've got a temperature sensor as well as a switch. You also have control units. Okay, you've got 2 ice protection control units that regulate the electrical, basically electrical part to, for the heaters in the drain mast. Okay, those are running there. There's an over temperature switch because you don't want to have it to be too high, so you've got an over temperature switch there that's installed in the drain mast, and it's going to stop that power supply if the temperature gets too high. What's too high? That's going to be at 250 degrees Fahrenheit height. Once it reaches that, it's going to cut that off. It's going to cut that heat. Okay, your wastewater drain lines, all of those, like I said, those have your heating assemblies. Okay, pretty straightforward with those. And of course, there's diagrams that show you what they look like. I mean, if you've been around aircraft, you know what these lines are lines. Okay, those are your piping that goes, that's all, organized there with that for the wastewater system. Okay. All right. So now you got control and indication for your water, wastewater ice protection system. Just so you know, this is automatically controlled. It is not manually controlled. The wastewater ice protection system does operate automatically. When you have, obviously, circuit breakers are closed, then you've got those signals going through, right? So all of that is going to just activate automatically. You got your control units again here to control the sensors and the heaters, etc. Okay. All right, so just a little bit on the drain mass assembly. Those, you've got the heating elements that are operating at certain temperatures. Remember I mentioned about the 250 degree earlier, like once it reaches that, it's going to cut it off because it's done, it's gotten up to that certain point. Here you've got an operation of temperature from negative 65 degrees or Fahrenheit to 160 degrees Fahrenheit for the drain mast heating element. Okay, that's its range of operation. Okay, now where can you find this? So locations, okay, location. All right, so forward drain mast, that is accessed through the forward cargo compartment, and there's a floor panel that you'll remove in order to access the forward drain mast. And then of course the aft drain mast is located in the aft cargo compartment, and there's a floor panel there that you remove in order to access that. So that gives you an idea there. All right, and then your control units, these are your ice protection control units for the wastewater. These are located, you got your forward and aft. Okay, so those control units are located in the forward cargo compartment. Okay, that would be for 2 of them actually located in the forward cargo compartment, and then there's one located in the aft cargo compartment. All right, and the heaters, you know, those are, you know, they're kind of self-regulated. I say roughly, they're kind of automatically run. Remember, I said there's a range too that they operate. So your range of operation there has an internal insulation, copper shield, which is pretty standard for the heaters, and then you have your protective sheath on the outside. The heater elements are in the forward cargo compartment. Okay, and just follow your AMM as far as your panel numbers. I'll leave that to, you know, to your AMM at where you work. All right, and you do have the bite test for the wastewater ice protection system. And this here, you've got different things that it's going to do. It's testing, monitoring the correct function for different things. Your interface connector, your relays, your sensors, obviously your heater elements, all the circuits involved. Okay, it's monitoring all of that, and it's testing to see, you know, testing for any faults in that whole system, all those different areas. And of course, if it detects a fault, it's going to be it'll be displayed. Now, the way you're going to start the bite test, you're going to push the test push button, and that was located on the top of the control units. Okay, so you'll see that at the top. Just push that button, and that starts the bite. Okay, there's going to be 2 LEDs that are going to show the correct status of the system. Okay, there's also a test menu, just like in any bite test. You're going to have your menus that are located in this place, displayed on the CIDS programming, and also your test panel. All right, and so, you know, I talked about procedures when you're doing bites. Is when you're doing your bite tests, you're going to have your power up, right? Your power up tests. Okay, that's going to be initialization and your cockpit repercussions. So those conditions there, power up, and then you also have your power up test. They're going to take about 10 seconds. Okay, so just follow again the AMM regarding the bite test, but just so you know what it's looking for, and you know where is it looking for faults. It's going to be in all the different things I just mentioned: your sensors, relays, your power supply, your interface connector, also the heating elements, as well as all the circuitry that's involved with that. And of course, we're talking about the drain mass. So if the message comes back, everything's good, then it's going to say drain mass test okay. Means everything's good. Test and pass the test. If it fails, then it's going to have drain mass heater forward or aft, whichever one is failing is going to be displayed there, and it's going to have fail. So it's going to fail. It's going to have that on there. Okay. Now there has to be also heat at the servicing panel for the water. Okay, so you have a water service panel. Those are heated. Okay, you got your water service panels. Those are heated in order to prevent ice formation on them. You got potable water service panel. You also have your waste service panel. So you got those 2. And remember I mentioned about the nipples. Your fill drain and your overflow nipples, those have heaters. Those are electrically heated with a foil heating element. Okay, and that's just kind of integrated as part of that, those nipples to ensure that there's heat there. Okay, your temperature thermostat's also installed adjacent to the nipple, and that's measuring that temperature as well. So it's kind of dual function. All right, so your potable water service panel, as well as your water service panel, those are located both on the lower fuselage shell. Okay, but your potable water service panel is on the aft left hand side, and then your waste service panel is on the right side. Okay, but those are both located on the lower fuselage shell. So you know where that's located. And a lot of the high range, in other words, the max range, you know, where it cuts off the heat, is going to be somewhere around 250 degrees Fahrenheit, just to give you a broad stroke of it, because it might vary a little bit, but it's going to be somewhere around 250. It might be give or take, you know, 22 or 20 degrees or so, but for most of what we're talking about, that max is there before it actually cuts off. It says, okay, it's heated up enough. All right, and just a little on the thermostat. Okay, and then we'll get into a little bit on the nipple heaters. But the thermostat, as you know, as far as that location, it's located adjacent to the fill drain nipples. Okay, so that's there, and that thermostat's connected to a heating element. Okay, so when we have icing conditions, they start to happen. The thermostat's going to turn on that heating element. It's going to heat it up. Okay, and that's going to create that heat necessary for that. Okay, and then with the nipple heaters, so we got your drain and flush nipple heaters. Those are electrically heated, and also there because you don't want to have damage, you know, to the nipples, which is why, again, ice can be very dangerous. We know, I forget which flight it was, but there was one in Northern Europe that happened because they got the wrong information, so they were heading the wrong direction, wrong heading, because the ice had formed on the probes. Okay, I know we're talking about water here, but I'm just giving an example of what happens when you have the formation on some of these components. You know, it's going to cause some problems. Okay, so that's kind of on your wastewater that you have there, and we talked about the drain mast. What about potable water? You know, we don't want that to freeze. We want to protect that from ice. You know, so this is installed there to prevent that ice formation in the potable water system. We don't want to have potable water lines, you know, with water freezing up inside them. So, you know, we otherwise, right, it's going to cause a big problem. We don't have that blockage there when we got maybe some water that hasn't frozen yet trying to get through, and now we got to back up. So we got to have heat to it. We got to put heat to it. So we have that. The water lines are insulated and heated by tape, they're electrical heaters, and they're strategically placed where icing, you know, are more likely to occur. Okay, so those are all there installed, and then your potable water lines that are installed. You know, we got some forward and aft sections of the aircraft. All of that there have heating assemblies. So just kind of giving you an idea with that whole system. And of course you have the control units for this as well. You know, for potable water ice protection, just like you have for wastewater. It's, you know, those are there to regulate that heat to that system. Okay, and you've seen some diagrams with heat tape and what that looks like. I mean, there's so many different kinds of temperature sensors. You know, you guys know that, but you know, you can again look at the picture, kind of get a feel for what these particular sensors look like for this application. Okay, now on the control, of course, your supply, it's electrically supplied. Your circuit breakers have to be closed in order to be energized, so that you have those signals, you know, communicating and going through to your control units, etc. Obviously, the sensors need to send that information to the controllers or the control units, and that's exactly what they do. Okay, there's 5 areas in the water supply that are installed where you have some kind of protection installed in the aircraft. There's 2 types of water line heaters. You have your inner line heater and you got ribbon. Okay, so those are the 2 types that are installed in 5 different areas of the potable water supply system. Okay, just so you know. And with the inner liner, the inner line heater, that's going to be receiving power from a particular bus. Just follow your AMM. Obviously, it's coming from a certain bus that's through the circuit breakers. Okay. The inner line heater, it has its own controller and its own sensor. All right. So supply line outboards. Let's just talk about one. We got the potable water supply line outboard of galley number 1. That supply line is protected by a wrapped heater with the sensor. So you got a sensor there. You also have one in the center wing area. So you have another potable water supply line installed in the center wing area, and that's actually protected by a ribbon heater. So just so you know, there's an example, because those are the two types of heaters, and your inner line heater is there to protect actually the electronics area. Okay, your electrical compartment. So you have heat going there, and that's an inner line type of heater that's being used there. But when we talk about the potable water supply line in the center wing area, that's actually a ribbon heater, and that's getting power from one of the buses, obviously, and or it could come from a receptacle from the external power panel. So either way. But anyway, I just wanted to share with you about the ribbon heater. Besides the inner line heater, how those are being used. You also have tail area drain, where you have heaters there as well, besides the potable water supply lines. Okay. Your control units, you can't control the system manually. It's automatic. The sensors are going to detect icing conditions. The control units are going to supply the electrical power to those heating circuits and also the inner line heaters in order to get that heated up and being able to obviously prevent the ice from forming. Okay. All right, and again, you can learn about which buses. I'd rather just leave it to your AMM because there may be some slight differences between the models. So we'll just kind of leave it at that. But just know, obviously, they're coming from one of the buses. Okay. All right. Now, what about the control units themselves? Okay. Remember, the control units are going to be controlling the heaters and also the sensors. Those control units are remember I said in the forward and the aft cargo compartments. That's where you're going to find those control units, and they're going to be monitoring those heater circuits. Okay, and so remember I said there's that range. If it gets to a certain degrees Fahrenheit, it's going to shut off that heating supply. Okay, so but that's what that does. That's what the control units do. It's going to be detecting. Okay, the sensor is going to be detecting the icing conditions, and the control unit will decide, okay, here's what we need to supply to, this heater assembly. All right, so a little on the line heaters, and then we'll kind of go into bite test with all of this. Okay, so with the with line heaters, okay, like I was saying before, you've got the EE compartment, your center wing area, and all your supply lines, okay, in galley number 1, etc. Okay, all of those areas is where you're going to have those heaters. Okay, and then the ice detection. There's an indicator that you have that's there actually in a different place, but this is going to actually be on the windshield, so we'll just leave that for now. But this gives you an idea with what we have when it pertains to water. We're concerned about wastewater and your potable water supply lines, where we don't want to have those freeze. So you've got all those heating circuits that are running through, running with those lines, providing that heat. And remember, there's a max temperature, where it reaches a certain temperature, it's going to stop that supply because it no longer needs to have, you know, that much heat anymore, right? Okay. All right, so that gives you an idea with kind of, again, just kind of getting some ideas with the water, the protection of water freezing. So now let's talk about, kind of go to the engine, because we want to be sure we, you know, don't have freezing going on around the engine air intake. It's very important not to have that. So we have heating elements there as well. Okay, so let's look at this with the engines. Okay, the air intakes, those have kind of a, we got an anti-ice valve there, and of course we got the control indicating, you know, for the operation of that. Okay. All right, so ice protection for the engine air intakes, we want to make sure there's no ice forming on the lips when ice is, or, you know, we got icing conditions. We want to maintain an inlet duct that does not have ice in it. That's extremely important. So we have this ice protection system here. It normally, we have that system of the intakes, which is normally selected only in icing conditions. Okay, so it's not like it automatically comes on, but if there's icy conditions, then it definitely is going to be utilized. Your ice protection heats those intake cowls with 5th stage air, okay, from the engine. And as far as like the different components that you have, when we talk about the ice protection system, you know, what composes the ice protection system for the engine air intakes. You've got your swirl nozzle, you also have a shutoff valve, your seals, coupling, ducting, and also your mechanical supports. Okay. You have an on-off with the shutoff valve, so it's not a gradation. It's just simply an either-or situation. You either have off or it's on the control of that. And then with your swirl nozzle, that's going to be controlling kind of the distribution of that air within the edge of the cowl. Okay. Now, what warning message would be associated with this particular ice protection system? This would happen if you have a disagreement between the position of that, okay, and the anti-ice valve control. So it's basically the control of the anti-ice valve, the position and the control of that. If there's a disagreement there, the warning message is going to be displayed. This is all also interfacing with the EIU, okay, your engine interface unit, as well as your zone controller. Okay, so those are your two other computers that this particular ice protection system actually interfaces with. All right. Now, as far as what you're going to see on display, you know, in the cockpit, you do have an engine anti-ice on indication that's going to be displayed in green. Okay, so green color means it's on. Okay. Then you also have the other things. You can have a fault legend, of course, for engine 1 or 2. In case there's any fault, that will actually be indicated. Now, if there's any central warnings whatsoever, then besides it showing up, you know, on the screen, you're going to have the master caution light come on, just like normal. You're going to have that come on, along with the single chime. So there'll be also that sound, along with the illuminated master caution light, which is in amber, as it always is. You're also going to have overpressure, so there's an overpressure indicator of that anti-ice valve. So if for some reason there's a mechanical overpressure, then there's going to be an indication of that. Okay, because we want to release that pressure. And that's going to be, you know, there's going to be a pressure reducer piston that will allow the release of some of that pressure. So when the pressure is between like 120 psi and 180, then the indicator will move to the extended position. It's going to pop out. It's like that's the indication. It's a mechanical indicator, and that'll let you know, okay, there's an overpressure. So remember, between 120 and 180 psi is when that pop out indicator, physical pop out indicator is going to, you know, happen. And that's going to be extended there. So when that happens, that means that there's a problem with the regulator in the valve, or there's an overpressure indicator. So, you know, could be either one. So there's a maintenance issue right there, or something to be definitely looking at if that happens. The regulator in the valve, that's the one that's used to do the pressure reducing. Okay. Now, if for some reason there's a failure of the regulator, just like anything else, you have a failure of the regulator, you're going to be wearing out, you know, putting stress on other components within that valve. So, you know, basically probably be time to change out the valve entirely. If there comes single, you know, as a whole assembly, then you'll just get a new valve. But anyway, bottom line is, if you have failures going on with that regulator, then you're going to be essentially, you know, like anything else, shortening the life of anything else that's in there, your components. Okay, so typical maintenance. Okay, that's standard maintenance. You're going to be wearing out other components there if something's not functioning correctly and it's running that way. You know, you're just shortening everything else in there. Your engine anti-ice valve, it's a butterfly shutoff valve. It's just it's an off and on type of deal, spring loaded. Okay, that's what it is. The valve's fully open in the event of electrical signal loss. So that'll be fully open if there's a loss of electrical signal. Okay. All right, so where are the engine anti-ice valves located? Okay, obviously they have to be near the cowls, so that's where they're at. So in case you want to know where's, you know, located, well, they're going to be actually underneath the fan cowls. That's where they're at. And of course you can see diagrams give you an idea, but that's what you have with the engine air intake protection against ice is, you know, is all right there. All right, so let's move to the fourth area or region or component, however you want to look at this, that we want to make sure there's no formation of ice, and that would be on your probes. And very, very critical to the pilot to make sure that those are, you know, not frozen up. The air data system is extremely important. So here you've got your probes and sensors, your pitot and your static probes, your angle of attack, and your total air temperature sensors. Those are all located on the fuselage, okay, in the zones that are, you know, more exposed to ice. Okay, of course you have your heating system. That's going to be a part of, you know, each of the probes. And so it's extremely important that those heating systems are working properly. If they're not doing its job, then they're going to, you know, we're going to have ice forming on these probes, and we definitely don't want that. So it's extremely important those are maintained on a schedule the way they should, or when it's not scheduled, there's a time where it's convenient, there it is, maybe you want to do a quick check and make sure things are working properly. Okay, so if there's some problem with the heating system, then there's definitely going to be a warning that's there. Now, with the air data system, there's 3 different detection channels. There's one for captain, there's one for first officer, there's one as a standby. Okay, so you have electrical heating of the probes there that are going to prevent that ice accumulation on the probes. Okay, so we've got, just kind of reiterate here, we've got the you got your pitot probes, your static probes, you got TAT sensors, and what I mentioned earlier, you got your AOA sensors, your angle of attack sensors. Okay, now one of the sensors that is not heated on the ground is going to be your TAT sensors. Okay, your total air temperature sensors are not heated on the ground. That may be a test question. Hint, hint. Okay. All right. So the ice protection system for the probes, just so you know how they're organized, because it depends on which ice protection system we're talking about, but here we are talking about probe protection. Okay. And so with here, we have 3 different channels, okay, that are independent. And so one of the channels, okay, we've got a controller for each of those channels. Okay, and your controllers are going to be monitoring the heating of those probes. So each of the controllers is monitoring one pitot probe, one TAT sensor, 2 static probes, and one of the AOA and one AOA sensor. Okay, and they're labeled appropriately, so that's actually PHC1. If you see that, we're talking about the probe heating controller. So we've got PHC1, PHC2, and PHC3. Okay, and of course you have interfaces with your landing gear absorber, your shock absorbers, and also your engine interface unit. Okay, your CFDIU. Okay, all right, so kind of just looking at the monitoring that goes on with these controllers. Okay, they are monitoring the heating for all of what I mentioned just a bit ago. Low heating, or there's an overcurrent, or there's heating loss or a discrepancy between the ground and the flight information. If there's a discrepancy there, then there's going to be an indication right away. It's going to be a warning about that. Okay. Of course, you got internal circuits. That's a given. You got internal and your externals. Okay. Okay. So, and that pretty much it gives you again an idea with as far as the probe heat controllers and the channels that are involved with the ice protection, anti-ice protection for this. Okay, for the probes. All right. So just kind of want to do a little bit of identification of where, a little bit of where they're located. We've got static probes that are flush mounted on the fuselage skin. Okay, and you have those internal heaters there. The power that's going to most of them, or I should say most of them, some of them are going to be your 28 volt DC. You also have your 115 volt AC that's going for your pitot probes. So you got your heating systems running on 115 for your pitot probes, and then you've got your 28 volt running for your static probe heating systems. Okay, and then just, to give you an idea of the particular heater elements that are involved, in this application, there's, some pictures that give you an idea what that looks like and kind of where they're located. Okay. Identification of, or description, if you will, of AOA sensor heating. I don't know how important or how much you want to know about that. Just saying, because there are so many different kinds of sensors that we have here. Just again, know that you have your AOA sensor that has its own heating, and so that it doesn't freeze, so that we don't have ice formation there. And we have power that's being supplied to make sure that the heating's going on there. Okay, so that gives you kind of a rundown with the probe protection. We protect probes from debris, but in particular, ice. Ice is a debris because it's hindering or blocking the function of those static probes, and all that. So, again, that's a very important part to protect. Our last area that we want to make sure there's no ice forms is the wings. Okay, so and I can tell you, Rick's going to give you some more information. We're going to have like a, we're going to get to it so that you can get a feel for the idea from a pilot standpoint, with the importance of maintenance doing, their great function of ensuring the safety of that plane, and the wings are extremely important. Since they're extended out there, You know, not to say that there aren't other areas like your pitot tubes, because they protrude also, but your wings are the greatest surface area that protrudes out and is capturing, you know, whatever formulation of ice that could be. So we want to make sure that there's an like a counter here, that when, you know, there's a possibility of that coming, there's just no way that it can form on there. So let's look at this. You know, obviously we have two wings that we want to protect. Okay, and so we're going to look at the anti-ice control valve. We've got anti-ice ducts. So we're going to talk a little bit about the two kinds of ducts, and those are on the test, by the way. You got your telescoping and your piccolo. Okay, telescoping and piccolo, those are your two types of ducts. Okay, those are your anti-ice ducts. And of course you've got your faults and your warnings and your bite test, which is, you know, always a part of that. So let's kind of look at this. Okay, so we're looking at the wing. You know, you've got to protect against icing conditions when you have those airfoil sections. You've got leading edge slats, right? Okay, you got leading edge slats. You got your 3, 4, and 5. Those are all thermally anti-iced by a manually selected hot air system. Okay, so it's taking that air from, from the engine, because you've got engine bleed air supplying just like you have with the other ones. So you have that pneumatic system playing a part here, along with the electrical system to, you know, for heating elements. Okay, so with the wings, you have the pneumatic system that's usually takes a supply of air from the engine, from the intermediate pressure. Okay, your IP bleed, and of course, you know how much, like we talked about in some other classes, is that you have engines when they're operating at low, or you know, let's say the engine's just idling, or we have very low RPM. Then it's got to switch, right? Typically it's going to come from your IP bleed, but if your engine is at lower RPM, it's going to start taking it from high pressure bleed. Whatever it needs to do to get that sufficient, okay, to meet that demand, it's going to pull. It's going to pull that and supply that pneumatic power to that. So that's what it's going to do for the wing ice protection system. Now you do have an anti-ice control valve, and that's just to keep, you know, the air at that correct pressure. Okay, so the air that's going to leave that control valve passes through the ducts in the wing. Just so you know how this process works, it's going to go through the control valve, it's going to pass through the ducts in the wing, fixed leading edge to a telescopic duct. So you got ducts going to a telescopic duct, which routes that air to the inboard end of the piccolo duct. That's going to be located in slat 3. So remember I said there's a telescopic and you've got a piccolo duct. And you're going to have those ducts, they're, you know, ducts that are going to be going to get that bleed air going through, and then passing through to the leading edge where the telescopic duct is located, and then it's going to be routed again to the piccolo duct in slat 3. So that way air is distributed along, you know, all those 3 slats, your 3, 4, and 5 slats, by those piccolo ducts. Okay, of course you have couplings, so those are all going to be there. You have flexible couplings as part of that duct system. All right, so then now you have those piccolo ducts are going to be releasing that air into the slats through the holes along that whole length. Okay, and the flow is going to be around the forward area of the slat. Then it's going to go through the acceleration slots into the rear. It's kind of a cool system, actually, the way it goes. But that's how it runs. In order to get all that air into that warm air into there. Okay, remember that's the largest surface area is your wings. So it needs to make sure it covers, you know, as much as it can there, so that you don't have that problem with the ice. Okay, now your interfaces are going to be similar to what we mentioned before, to your SDAC, your ECAM, your CFDS. Also your landing gear oleo proximity switches. Okay, it's going to interface with those, and then also with your control switch. I mean, obviously if you have an anti-ice valve, you're going to have interface with your control switch. So that's what you have there. And of course you have, remember, if you recall from other other information videos here, you've got a cross-feed duct, okay, and that's going to be supplying, when we talk about pneumatic systems, there's a cross-feed duct that's going to be able to supply the two wings from one engine in case for whatever reason you're not able to get it from, from one engine where it's supposed to be supplying. The other engine can actually make that supply to the other side. Okay. So with anti-ice for the wings, you do have a push-button switch, and there's two choices: blue and amber. Blue, remember I said blue means it's on, so you have, like in some other applications, the blue means that it's on. Here, it's the same thing. If it's illuminated blue, that means that the wing anti-ice push button switch is on. And if there's a fault, if something's not working with that system, then the amber light will be illuminated, and that will say fault. Okay, so when does the fault light come on? What's going to trigger it to show on the display like that? Well, there's different things. One reason if you have, the left or the right valve, just fails to open. Okay, so then that fault light's going to come on. You can also have the changeover relay that doesn't operate, or fault relay. So any of your relays that don't work, the fault light's going to come on. The left valve air outlet pressure, if that's too low, your left or your right. So output pressure or outlet pressure is too low, or the valve fails to open or close, or you have relays that are not working right. Those are all good reasons why the fault light's going to come on. Okay, so those are your controls and indications. The valve, there's two wing anti-ice control valves. There's one in each of the wing leading edge outboard of the engine pylons. Okay, so you have one on each side. The on and off switch, is in the cockpit overhead panel. And what the valve's going to do is going to isolate the anti-ice ducts only, from the pneumatic system bleed air supply. And that's going to be doing that. It's isolating it when there's no need to, it's going to control that valve. If it's not necessary to have the anti-icing going on, then it's not going to allow that to even function, right? Because it's not necessary. It's also going to control the pressure of the bleed air. So that's what that control valve is doing, that wing anti-ice valve, control valve. Okay. The valves, I know I talked about all this while I've been talking about, I'm talking about heating the windshield and the windows and all that in the pros. I was always talking about electrical heating. I was always talking about, this is electrical, be careful, make sure you follow safety procedures at your, per AMM, and what's set out, because, there's electrical, live electrical power. Here we've got pneumatic power, but you have valves that are selected electrically and actuated pneumatically. So, they're selected electrically, but as far as their actual, movement, or moving, as we're talking about, they're moving by the bleed air. Okay, so pneumatic power is involved, with this. Right. Okay, your ducts, remember I said there's two types of ducts, telescopic and your piccolo. So, right, so when I'm saying this, you've got your telescopic duct, that has 3 sliding tubes with couplings at each end. Okay, so how that is described, you've got that, that makes up that telescopic duct. And as far as your piccolo ducts, those have 3 rows of holes that face the leading edge skin of the slat. So as far as their design, they're different. Your telescopic duct has 3 sliding tubes, and then you have your piccolo ducts that have 3 rows of holes in them. And the holes are just there to release that hot air, right? That's the whole thing of that, having ducts, is it's moving that and kind of conducting, if you will, conducting the air where it needs to go, that warm air where it needs to, make sure it stays at a certain temperature so that, no ice can form. Telescopic duct is at a certain track. Do follow your AMM as far as, where exactly that's located. Okay. All right. There's also, of course, I know I mentioned about the fault. Remember, if it's amber, obviously you have a fault going on, and okay, what could trigger the fault? You know, valves not opening, you know, things like that. So, you know, those are reasons why it would come on. There's going to be a delay, as far, like, there's going to be like about a 10-second delay before the warning messages that are going to show up on the ECAM. Because, you know, there may be some warnings that aren't necessary because just low pressure is there. So it's kind of like an extra verification, giving extra time for verifying that that's truly a warning message that needs to be shown. So just so you know, that's what is happening there. And then when you have the system turned on, fault light's going to come on until the pressure is above a certain limit. If you have the system to be shut at the off position and the control valve is not closed, okay, so you have that. After the aircraft has landed, and if the control valve is not closed within 35 seconds, then the amber warning is going to come on, and then you have the chime that comes on, and then there's going to be a warning on the ECAM. So that control valve should close after landing. Okay, not immediately, but a little bit of time, and then it should shut off. Okay. All right. And of course, again, kind of a picture gives you an orientation of what's on the panel itself and what it looks like. And of course, you got your bite test. So you're running your test sequences for that. You know, just hit the control switch on, and you know it's going to monitor all of that whole system. Okay. All right. So that gives you a pretty good idea with what we have with the different areas that need to be protected against ice and rain. So I just want to do a quick summary. Number one will be your cockpit. Okay, what's in the cockpit? We got a windshield that the pilots are looking through. So the windshield in front of them, and then also their side windows. Okay. Number two is going to be the water that's on the aircraft. What kinds of water? Well, you got your wastewater, and you have your potable water. So you got all your drain lines, okay, that you want in your supply lines, right? Your supply lines and your drain lines, you want to make sure that when water is running through, that they don't freeze within the line, because now then you have a blockage, and whatever's in the line that hasn't frozen yet is now getting blocked because ice got formed in there. So we don't want to have that. So that's another area that we're trying to protect. Number three is going to be the engine, being able to protect the engine air intakes. We don't want to have ice form around there, so we have an anti-ice valve for that area. Number four, we talked about probes and how important it is to the pilot. Obviously, you don't want to have debris hindering the pitot tubes, all of those probes, static probes, your pitot probes, your sensors. So we have that area that we want to definitely make sure that maintenance is done properly, so that those heating, whether it's the controllers or the heating elements themselves that need to be switched out, that those are done. Number five is going to be your wings. There's wing anti-ice protection. And remember, there's two types of ducts, because we have ducts that are going from telescopic to piccolo ducts that have the holes in them to distribute that bleed air. Okay, remember, bleed air is going to come, this is a pneumatic system for when we're talking about the wing anti-ice protection. So we want to make sure that we have enough, force, if you will, coming from intermediate pressure stage. If for some reason there's too much low RPM on the engine, then it's going to steal it, if you will. It's going to take it from high pressure stage, and then it's going to supply that demand. So I hope that gives you a good idea with what we have on the aircraft for ice and rain protection. And we also have some knowledge checks, so I might as well throw a few in right now. This is not going to be comprehensive. There are going to be more questions on the test, but just, you're going to be given the questions, so you'll have that at your fingertips. And of course, if you have any questions about any of the question, feel free to email us. But certainly we'll do a review as well, so you don't panic. There's no reason to panic. But let me give you an idea. Here's one question: what components and/or systems need to be protected from ice and/or rain? Okay, so option 1, the wings, the engines, the passenger windows, the cockpit windshield. Option B, the wings, the engine air intakes, the wastewater, the potable water system, and the windshield. Okay, the more correct answer is actually the last one I just said. It's the first answer didn't even cover water, and yet water water freezes. So we want to make sure that water is included there, that we're trying to protect it from freezing. Okay, so now next question or statement. The anti-ice and defogging system for the windshield is automatically started when the engine starts. Is that true or false? Okay, that's true. All right. Which probe of the air data system is the one that's not heated on the ground? Is it static ports or your TAT sensors? Okay, I remember I mentioned that it's actually your TAT sensors. All right. Pressure control shutoff valves control the airflow for the wing anti-ice system. Is that true or false? Okay, that's true. It does control the airflow. Okay, how long can you run a test of the wing anti-ice system? Okay, for 30 seconds or 30 minutes? Okay, 30 seconds. Or excuse me, 30 seconds. Where are the wing anti-ice control valves located? Okay, option A, in each wing trailing edge inboard, or in each wing leading edge outboard of the pylons. Okay, it's the second answer. Okay, it's B. Okay, what type of ducts are in each wing? Okay, and actually they're both, but okay, I remember I said piccolo or telescopic. Okay, the type of ducts are in each wing, you get piccolo. If you have any questions about the questions, by the way, please feel free to email. I don't want you to ever feel like you don't understand the question. Certainly give us feedback. I want to make sure it's clear for everybody. When the bike tests run for 35 seconds or more, what warning displays? Is it shut down pneumatic system? Because that's what it will display. Shut down pneumatic system, that's option A. Or option B, shut down hydraulic system. Okay, it's shut down pneumatic system. Remember I said there's only two systems involved here with ice and rain protection. You've got your electrical and your pneumatic. Hydraulic was not mentioned. How do you access the wing anti-ice system through the CFDS? Okay, I probably didn't mention this, but here you're going to get the answer. Okay, how do you access the wing anti-ice system through the CFDS? Okay, is it through the WAICTL push button or through the temp control of the air conditioning class 3 faults? Okay, the answer is actually the last answer I just said. Okay, there's a indication that says TEMP space CTL. Okay, so think about that because that's the answer, and that's how you access that. What comprises the ice protection system for the engine air intakes? Okay, is it A, mechanical supports, swirl nozzle, couplings, valves, seals, and ducting, or B, ducting, seals, couplings, and valves? Okay, remember it has to be comprehensive with the answer. Okay, it's the first one. How many duct sections are there in the ice protection system for the engine air intake? Is it 4 or 6? Probably didn't mention, but there are actually 4 sections. Okay, 4 duct sections in the ice protection system for the engine air intake. How many channels are there for the ice protection for the probes? Is it 4 or 3? Okay, remember I said there were 3. Okay, the answer is 3. The channels for the probes are controlled centrally by one probe heat controller. Is that true or false? It's false. Remember I said there was one for each probe channel. Okay, so that gives you an idea. We'll see how many questions there actually are for you. But don't panic. Like I said, if you have any questions whatsoever, even while you're in the middle of a test, if you don't understand the question, I don't want you to be penalized because you didn't understand, the question. But we'll do our best to present it as simply as we can. We don't want to make it so complex per question. We're not trying to create PhDs here. We just want to make sure that you have a basic understanding, and in some cases maybe a little bit more detailed understanding of some of the systems. This concludes the ice and rain protection for the Airbus A320. If you do have any questions, do feel free to email us, and we look forward to providing more information for you with the other topics.